this is an unknown coefficients question. You're taking the information you learned on Monday and the last 2 days and you're putting it all together. Okay, so it tells us if c by all of this plus b is equal to this quadratic expression, for all values of x, find the values of a, b and c. So straight away you might not be sure what to do. You've got a set of brackets, you can multiply them out. So it's going to be c multiplied by, and then you're going to use the quick method to do this. Square the first, square the last, first by last by 2. So it's going to be 2ax. Okay, it doesn't make a difference if you write the ax or xa. And then plus b is equal to 3x squared minus 6x plus 5. So then you're going to multiply the c in, so it's going to be cx squared minus 2acx plus a squared plus a squared c plus b, and that is equal to 3x squared minus 6x plus 5. So what we can do then, the coefficient in front of the x squares are going to be the same in both, since you know that they're equal. So that means that cx squared is equal to 3x squared, so that means c is equal to 3. So we found one of them already. Taking the coefficient in front of the x's, we know that they're also the same. So then we can put them equal to each other, and that is equal to minus 6x, so we can get rid of our x's straight away. So then, and we know that c already is 3, so that's going to be minus 6a is equal to minus 6, so that means a is equal to 1. And then the final one is the fact that a squared c plus b is equal to 5. We already know a is 1, so that means 1 squared is 1, multiplied by 3 is 3, plus b is equal to 5. So 3 plus b is equal to 5, so that means b is equal to 2. So even though it looks a very difficult question, it's actually not that bad. So this question here, if this is a factor of this part here, find the value of p and r. Okay, so you're trying to divide it in. X squared divides into x cubed, x times. X by x squared is x cubed, x by px is plus px squared, and then x by r is plus rx. So then you do the same steps as you normally would. You're going to change the signs and you're going to add the lines together. So then it's going to be, these two cancel each other out, plus 2px squared minus px squared, you're just left with px squared. This one here, 9 minus r, is, you're just going to leave it as 9 minus rx. It's much easier if you just leave it like that. And then you're going to take down your plus 2r and repeat the process again. X squared by what will give me px squared, so it'll be x squared by p. So then it's going to be p by this, and it's going to be px squared, p by this part here, which is equal to p squared x, and then p by r, which is just plus pr. So then that means before we change our signs, it tells us already that this is a factor, so that means we've got remainder 0 when we change the signs. So that means when we change the signs, they all cancel each other out. So that means before, when we change the signs, these two parts are equal, the coefficient in front of the x squares are equal, the coefficient in front of the x's are equal, and the constants on their own are equal. So that means we can go 9 minus r is equal to p squared for this part, and over here we can go 2r is equal to pr. So straight away I can divide across by r on both sides here, and I can see that p is going to be equal to 2, and I'm going to use that information then over here. So it's going to be 9 minus r is equal to 2 squared. Best to take my r's to the right hand side because you'll keep them positive. This is 4, 9 minus 4 is 5. So my r is equal to 5 and my p is equal to 2. Now the previous question, it was a long division question, but you had to find the values for p and r. This one here, you just have to prove certain things are equal. Okay, but we're going to do the same process. Okay, so we're going to divide it in. X squared times x would give me x cubed, and then we multiply that out. So it's x by x squared is x cubed, x by minus ax is minus ax squared, x by b is plus bx. And then we repeat the process, you change your signs, and you add the lines together. So this one here, they cancel each other out. This one here, you're left with ax squared, and this one here, it's just going to be plus c minus bx. And then you're going to take down your plus d and continue the process again. what x squared by what will give me ax squared, so it will be plus a, then x by that. A by x squared is ax squared, a by minus ax is minus a squared x, and then a by b is plus ab. Now, like we said for the previous one, if you change your signs and add the lines together, that means that you would get remainder 0 because it tells us it's a factor. So that means before we change our signs, we know that the coefficient in front of the x squareds are the same, the coefficient in front of the x's are the same, and the two constants on their own are the same as well. So we can write that information down below. So we've got c minus b is equal to minus a squared, and then over for the second one we have the information that d is equal to ab. Now, keeping this here in mind, these are the two things that we're trying to prove. We are almost there for this one. There's just a few signs that we need to work out. So we're trying to get b on its own on one side. So we're going to keep the b over on this side, and we're going to take this over and change the sign. So it's going to be minus b is equal to minus a squared minus c. And you'll see all we have to do to prove the first one is to multiply across by minus 1. You're basically just changing the sign of everything. So you're multiplying by minus 1, you're left with b is equal to a squared plus c, and that is the first one proven. Then to prove the second one, we can't do anything there just yet. But you should notice something. A cubed plus ac, we already know that b is equal to a squared plus c, so how about if we change our b to that? So it's going to be d is equal to a multiplied by a squared plus c, and then multiply out my brackets. So d is equal to a cubed plus ac, and there my second one is done.